Alright guys, so this is day 3 stuff. We're going to talk about homework in the book versus Delta Math assignments. Now I know this isn't regular school, this is outside tutoring, but at the same time I want to encourage you to do your Delta Math because 4 of you did not even attempt your Delta Math. You have 0%. Now this is not to get you in trouble, but this is to hold you accountable. I'm going to email your parents if you have that right now, because I want them to make sure that they know whether you're doing your part or not. Okay, this is not to get you in trouble. It's just make sure that they get their money's worth, quote unquote, and you are doing what you need to make sure that you are progressing. 3 of you already did the assignment, and I'm very appreciative of that, and you got the full 100%. Now I'm not going to pull that up and show you who those names are, but please make sure that you hold yourself accountable and do the work that you need to. Alright, I forgot to mention this last time. Come with questions always. Okay, so when you read the book, okay, the book, like, I can't see whether you read the book or not. The only way that I can see whether you read the book or not is as we go through those chapters, they have drills. So if you can follow with me, please, go ahead and turn to chapter 11, which starts back on 148. And it starts at 148 on chapter 11. If I go through all the reading, there should be notes on all your reading. Okay, so the pages that you did, there should be notes of what you actually read and what you drilled. Okay, there are drills too throughout the chapters. Like for instance, for this first chapter that you had for homework, the first drill was like on page 157, reducing fractions, adding, multiplying fractions. I want you to do those drills as you go through as well, okay? And then at the end of each chapter, okay? So the end of each chapter I'm looking at, please go with me, go to 171. So on page 171, you see no calculator section, fundamentals drill number 1, and fundamentals drill number 2. And guys, look at that. On page 174, there are all the answers in case you had questions. And starting on page 175 are all the explanations to the ones that you might have had questions for. Okay? Gut check. You and I both know on first day that we talked about this, it is a lot of work. Okay? You are conditioning, you are practicing for this SAT coming up. But it's not going to be like this all the time. Okay, so once you take the test, you can kind of relax for a little bit, jump back into it if you need to ever take it again. Okay. My theory is work hard right now so that you can enjoy later. Because if you don't work hard right now, and let's say you're working about this, and you're going to try to continue to go up, you're really never going to be able to play because you never even hit this level. Okay, so just a little picture just to help you out. Please motivate yourself, push yourself, do the homework. Alright, so are there any questions that you have from chapter 11 or 10 for me? Does anyone have any questions handy? Or do you have questions from the homework that we did that is due today that you'd like to kind of discuss? Okay, so I'm going to give you time just in a little bit. I'll pause the video. I'll let you look through the chapter real quick. We'll kind of skim and go through, make sure that we did, in fact, look at the things that we were needing to obtain from the chapters 10 and 11. And then if we don't have any questions, we will move on to looking over the diagnostic results, doing more of these questions that came from your test that you did that day 1. And then sure enough, if we have time, we can start on chapter 12. Okay? Alright, so let me pause the video. I'll let you peruse for a little bit, find questions if you have them, and then we can discuss and record them together. Alright, so going over the ones that you just did, just now, we're going to go to, on page 173 in your book, we're going to go over 20. Okay, so it says if 4 to the x times n squared is equal to 4 to the x plus 1, and x and n are both positive integers. That's 1, 2, 3, so on and so forth. What is the value of n? Okay, so we're trying to find what is this n going to equal if this would equal that. Okay. So to get these to be the same, we know a rule in math that if I'm multiplying things with the same base, that you would add the power. So if you have something like this, and this n was 4, this would equal 4 to the x plus 2. Okay? So if n was 4, I'm just kind of throwing it out there, if it was, we would end up adding those powers together, and that does not look like that. You with me? So we know for a fact that n cannot be 4. Does that make sense? Okay, so we're going to discover what could n be so that this would be the same as the left side. You with me? So, and it's easy to forget that. Like, it's easy to forget those rules and all this math that I'm doing, that some of you will probably look at this and you'll try to plug in some numbers. So let's go ahead and let's try to plug in 2. Okay? So A, it said, what if n was 2? And if n was 2, we're going to see, can we make this right here with n being 2, can we make it look like 4 to the x plus 1? Okay? Guys, what's 2 squared? 4.
It says 4 is the answer.
It says 4 is the answer. What is the value of n? Are you sure you're looking at the right one?
On page 176, 20 is B.
20 is B. Ooh, it might be a miss. Because if it's 4, that would be 16. And you don't necessarily get that. It might be a misprint because look, if n is 2, do you agree that this is 4 right now? Okay? And then this would be 4 to the x. You with me? So 4 to the x times 4 is the same as 4 to the x plus 1. You see what I'm saying? So then they would match. Yes?
In this part of the equation, on the right side, it's multiplied by n.
Oh, okay. So I was missing this part. I got you. No worries. So for this, yes, it would be 4 with this n attached. But nonetheless, did you see what I did though? Did you still see of how did we combine those bases? How did we throw in numbers to get this piece to match up with the rule to the right side? So no worries. We could do 2 problems just now, okay? The one that we originally did, n would be 2, would make it work, okay? So let's go ahead and now do the one that it was actually. So we'll add this in now. So 4 to the x, n squared, and then we have this n right here, okay? So we still learned a lot from that, okay? What do you see as far as what's in common between the two? Like, what's most important right now is this multiplication and this multiplication. You with me? Because this n, to kind of get them to look alike, what is this n over here? It's just 1, right? So, again, we can plug in test points right now. We can go through them and say, what if n was 2? What if n was 4? And so on and so forth. So real quick, let's just test that out. Do you see how this, if n was 2, would be 4, and this would be 2 over here? So we would have 4 to the x plus 1, and then we would have 4 to the x. So you have 16, and then you have not 16 over here. Okay, so look. This is 4 to the x plus 1. You with me? And what would this give me 4 to the x plus 1? It wouldn't, right? Because 4 to the x plus 1 times 2 is not going to give us 8 to the x plus 1. Okay, so you can see by throwing that in there, it's not going to give you the same left and the same right values. Let's go to 4. If I threw in 4, over here I have 4 to the x plus 1, and then 4 to the 1. Okay? What do we do with powers when we are multiplying with the same base? We add. You've seen it like x squared times x cubed is x to the 5th, because we are adding those powers. So that's a big thing that it's looking at here, because if this n is 4, what is that going to become? X plus 2. What is this going to become? X plus 2. So it would be 4 on this one. Okay? So what I would say on these, it is a good idea to kind of test point, trial and error these points. Or you can try to see if you can simplify and try to solve for n all by itself. You see what I'm saying? So let's say, looking at this right now, if you were to divide both sides by n, that goes away. How many n's do you have left on the left side? How many n's do you have? If you have n squared over n, how many would you have left? 1. Where would it be? The top. So you'd have 4 to the x times n. You would have 4 to the x plus 1. This is if you don't test it. If you don't test it with your answers and you're trying to do the math, this is what you would want to do. Because what would n, and we saw it moments ago, have to be so that you could add these powers to become this? It would have to be 4, because then you would add x and 1 to get x plus 1. Does that make sense? Okay, so adding powers whenever you're multiplying with the same base. Okay. Alright, what's another problem that you guys want to go over? Because there are a lot.
Number 6 on the non-calculator.
Number 6 on the non-calculator. That's a good one. That's dealing with powers, and a lot of people struggle with these for sure. Let me make sure I read the question correctly. 9 to the negative 2 is equal to 1 over 3 all to the x. And we want to know what is the value of x. Okay? First of all, right now, with where you are probably at with Algebra 2, you've experienced these negative powers. Okay? If you haven't, let me show you what a negative power means. This 9 to the negative 2 is like all over 1. And negative powers mean if you have a negative power, you're going to move this number across that division symbol. So this 9 is going to drop down to the denominator, and it's going to take that 2 with it, but it makes it positive as it goes through the division symbol. Okay? So however you want to do that, guys, to remember it, whatever you need to do, I don't know, I probably just kind of remember that you can't have negative powers, and going through this, I don't know what you want to say, just fraction line, magic fraction line, whatever, it makes it become positive on the other side. What's left up top, guys? What number is going to remain on the top? 1. Now let me ask you this. Is that because this 1 went upstairs? It wasn't because of that. It didn't flip the entire denominator. Please don't be afraid to make a mistake. I just made a mistake, and it's okay because we still learn from it, okay? No, you don't rotate this as far as make it a reciprocal. There's an understood one left up top. Okay, so right now we have this looking at us. Okay? What number just kind of screams at you right now? The 9 squared, right? So the 9 squared, if I wanted to make this look like the right side, I need to know some Algebra 2 rules. 1 over 9 squared is the same as if we were to do that. And the reason why is because when you have, and you're doing it with like square roots and squares, right now, probably in your Algebra 2 class, when you have something raised to the 2 power, it's like distributing it to the top and to the bottom. That's what this means of 1 over 9 quantity squared. Okay? Guys, what's 1 squared? 1. What's 9 squared? 81. But my point is that we were able to move it to this form here from this. Okay? So now I have 1 over 3 to the x. We're almost there, right? What do 9 and 3 have in common? 3. So I could look at 9 and change this to this. So 3 squared is 9. And it's equal to 1 over 3 to the x. And the reason why I did that is because now this 2 can come out as well. Okay, does that make sense? This 2 can now come out to where my base will be 1 over 3 all to the power of what? 4. Nicely done. And I've made it look like my right side, which when the bases are equal, guys, that's what our goal was, to get these equal, because they're not important anymore. Once they're equal, they're not important. It's all about solving for what's left to be equal. So what would x be? 4. Okay, these are good questions, by the way. Okay, there's easier ones. Don't be afraid that you're going to ask an easier one. That's okay. But these are good questions that you're contemplating. All right, what other questions do you want to work?
Number 1.
Number 1.
On the non-calculator.
Okay, 1 on the non-calculator. It says, which of the following represents the statement, the sum of the squares of something? So the key word here is of. And it's like a prepositional phrase. Okay? Those prepositional phrases that we learned in our English classes is when you see an of, it's like the beginning of a parenthetic piece. Okay? So this one says the sum of, so we know we're going to be adding between some things, between the sum of the squares of x and y. Okay? So the squares of x and y is saying the squares of x and the squares of y. Okay? And we're going to be getting the sum of that. So there's the sum. And it says it's equal to the square root, there's that word again, of, so it's like the parenthetic piece, the difference of x and y. Difference is subtraction, and you would get that. Okay? Questions? All right, so what's next? Yeah?
I just have a question about number 14 on the calculator part.
Okay.
If there was like a way to do it without just plugging in
Plugging in numbers and stuff?
answer choices, yeah.
All right, so let's look at number 14 on the calculator part. This is page 173. whoops. So it says, if each number in the following sum were increased by t, the new sum would be 4.22. What is the value of t? Okay, so now, if I have my numbers, and the big key word on this is that it says each. If each number were increased, okay, so each number in the following sum, so if this was increased by t, if this was increased by t, you'll see what I'm doing? Then the new sum would be 4.22. The old sum was just 2.74. The fastest way to do this is, how many t's did I add? 4. And by doing that, it gave me 4.22. Okay? So real quick, some of you might be aware of this, some of you might not be aware of this, but this is SAT, and the calculator that is allowed on SAT is this Inspire. Okay? So let me come over here, and what we're going to do is we're going to solve for this equation. Okay? Those of us who have older calculators, we would have to do this by hand, but if we're using the Inspire, we can tell it to solve for us. We're going to say solve for this answer right here. Okay, so here we go. And those of you who are wanting to do it by hand, just subtract by 2.74 and then divide by 4. Okay, and then you would get it. Those of you who like to be efficient and faster than everyone else, you would do it like this. Menu, algebra, solve. Okay? When I was a kid, this would have been very, very nice. 2.74 is going to be added with 4t, so plus 4t, and it's equal to, here's that equals button, and we're going to say it's equal to 4.22. What are we telling it to solve for? T. So comma t. Tell the calculator what to do, and it'll give you the answer. Cool? Alright, what else?
Number 4 on the non-calculator.
Number 4 on the non-calculator. Okay, so number 4 on the non-calculator, let's see what math is going on there. We have a is equal to -2, and we're saying a plus a squared minus a cubed plus a to the 4th minus a to the 5th. The big thing on this one is they want to see, do you know how to substitute your values correctly? So if I put this here, 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 and here, they want to know, did they use parentheses correctly? So this, and that. So if you plugged in -2, you have to put -2 in parentheses, because, here we go, what does this -2 squared become? 4. Okay? What does this -2 to the 4th become? 16. And you notice they're positive, right? Because these powers will make it positive. So it's adding this positive 4. It's adding this 16. Look what happens here. What's that? -8. And I'm subtracting this -8. And that's where they want to see, do you know that this is actually adding 8? You with me? Okay. So this right here, this -2 to the 5th, is going to be a negative because it's an odd number. So it'd be a -32, but you have to subtract that -32. They want to see, do you know that 2 negatives make a positive? So you're really adding 32. This one was -2. That was the only one that remained negative. Okay? So it's just -2 plus all of that. And so you'll get your answer. So I see this, just make that 30. There's 20, so that's 58. Okay? All right. Any other questions? If not, we can go through the chapter and look at the drills too. Okay, so this is what we'll do. I want you to write these very important rules down because there are a lot associated with Algebra 2 rules that this chapter is really honing in on. Okay, here we go. The examples that I have are if it's x cubed times x to the third, it would be x to the fifth. Okay. If it was x squared raised to the third power, what would that be? X to the sixth. Okay. The other thing is, when you're combining like terms, can you combine the like terms? It depends on what you're looking at. Okay, couple more things that I want to add to this. The square root of m times n is equal to the square root of m times the square root of n. You might have seen that on your Delta Math. Those of you who did the Delta Math, you saw this a lot. You can divide it and break it up if you are multiplying inside. But if you are adding, they like to test you on this. This is not mathematically legal. Those are not the same. Okay? And then the last one is the square root of m over the square root of m over n, like a big fraction, will look like this. And these are rules the same as if you had the square roots independently that were multiplied. In this case, division is a form of multiplication. That's why those are legal. Okay? All right. For instance, let me see. Can I add those together? I actually can. Because look, I want you to think about it like this. Let's say square root of x, or 2, is x. So guys, if I substituted this with x, what I'm really looking at is this. Can you add those two together? What's 2x plus 3x? 5x. And if I went back, this is the same as 5 root 2. You with me? Okay, so now let's change it up. What would 2 root 2 times 3 root 2 equal? This is different. It's going to be 6. For those two parts right here, that's 6. And now, what would these give me when I multiply? What's root 2 times root 2? We just found a rule. What's root 2 times root 2? Root 4. This is the same as if you were to put them both underneath as 2 times 2. So what's root 4? 2. So your answer would become what? 12. For this part, it would become 12. That's the difference between multiplication versus addition with like square roots and these rules that we're talking about. Okay? Alright. Let's see. Kind of perusing through the chapter, making sure we're good to go on these rules. read the chapter, guys, if you didn't read the chapter, please, 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 make sure that you note page 162. Put a bookmark, bend the corner, put a red pen or something so that you will know right before you go to test. You want to make sure that you're always looking back to 162. Okay? And then the last one that I'll do on this list of rules, because there's a lot of them, is whenever you're dividing by the same base, let's say I had 5 and I was dividing by x to the 7th. This is the same as if I had 5 x's up top, 7 x's on the bottom. 5 will cancel and you just have 2 left. So this is the same as reducing to 1 over x squared. The rule is this: subtract your powers. So 5 minus 7, you could have also written, because over here when we were multiplying, and I'll highlight it, I'll highlight it so you can follow me. Again, you'll be able to watch this later if you'd like. When you are multiplying with the same base, you add their powers. But when you're dividing by the same base, you're going to subtract 5 and 7, which could have been a -2. So on page 162, it's showing you that x to the -2 is the same as 1 over x squared. Because x to the -2 over 1, just like we talked about on this other problem before, when I have a negative power, it's like moving that piece down to the denominator and making the positive power happen. Okay? All right. What other questions do y'all have? All right, so let's go ahead and move into, we're just going to start it. I want to move into chapter 12. So go to page 181. And a couple things that I want to look at. Again, you'll have this for homework. And weekends are a little bit hefty, guys. Your homework assignment, whenever it's between Tuesday and Thursday, it's about 30 problems, 30 to 40 problems at most. And then over the weekend, it's about double. Okay, so you have about 70 problems over the weekend. I know it hurts, I know it's a lot, but that's the practice you need to score higher. Otherwise, you know what I mean, you're just going to be hitting that same score. Let's move on to, I want to move on to number 29 on page 186. I want to see where you're at with some things. So page 186, number 29, that exercise drill problem. And the answer is right there underneath, but we'll get to that in a minute. It's the square root of t plus 4, and it's equal to t minus 2. And it says solve for t. There's a nice calculator right to the left of it. We're going to do it without the calculator to learn some stuff, and then we will check it with the calculator. Help me out, guys. What do I do to solve for t?
First you'd have to
Square both sides, right? Okay. If I square the left side, you probably just finished this in Algebra 2. Squaring a square root, what happens? They cancel out. And all you're left with is what's underneath that square root symbol. Who can tell me what the right side is going to equal? Probably going to be
t squared.
t squared. So if you have to write this, please do. T minus 2 squared is not equal to t squared minus 2 squared. SAT and ACT love to test that because a lot of people think that those are equal. This is actually t minus 2 written twice. Why is it written twice? Because of that thing right here. You see it? So when you FOIL this out, first, outside, inside, last, Houston, what would I get?
T squared minus
Minus 4t, right? And then
yeah. Yeah. 4t minus 4.
minus 4t plus 4. Plus 4.
Oh,
Okay? So guys, let's watch where this came from. The first ones will multiply to give me t squared. The last ones, a negative 2 and a negative 2, gave me a positive 4. And then the inside terms, a negative 2t, and the outside terms, a negative 2t, will give me negative 4t's. And now I just got to solve it from here. Okay? Guys, you have a t, you have t squared. What have you been doing in Algebra 2 to solve these out?
Set it equal to 0.
Nice, perfect. Set it equal to 0. It's Jack, right? Nice job. All right, so from there, I'm going to move this t by subtracting it. That means there's minus 5t's over here. I'm going to move this 4 by subtracting it. That goes away. And I'm left with that. A lot of algebra happening right now. Help me find the answers for t. What do I do?
You take out the t.
Perfect. Nice job. I GCF out. It's Cameron, right? Taking out a t, what's left inside?
T minus 5.
Nice. T minus 5. We've done a unit on this not too long ago in our Algebra 2 classes. What are my answers for t? 0 and plus 5. Okay? Here's the thing. The next thing that SAT and ACT like to do is they give you this original equation. Let's go back to that original equation. And they expect people not to check their answers. Let's check our answers. If I plugged in 0 right here and here, would 0 work? No, because 2 is not equal to negative 2. But if I plugged in 5, would 5 work? Yeah, because 3 equals 3. So this is called an extraneous solution, and the answer would be D. Okay? Now, you may get lucky sometimes, and you may get something like this on the calculator. Menu 3, 1. The square root of, I'm just going to put an x plus 4. Kick out, say that it's equal to x minus 2. What am I going to comma? X, because now I'm looking for x. And it will account for that extraneous solution. It will only give you the one that is correct. Okay? Questions? Alright. So let me see what else we can look at. That's a quick, easy one. Let's look at number 9 on page 187. So number 9 on page 187 kind of goes with what we were just talking about. It says the square root of 5 is equal to x minus 2. Alright. And then it says, what is the value of this? Guys, what's the answer? What do I do? My goal is to get x minus 2 squared. And this is what I've been given. But I want to find that. Okay? My hope is that you don't try to solve for x. Some people might try to do this. And then they will take that and they will put it here. Just to see that the square root of 5 plus 2 minus 2 would go right back to the square root of 5. And what's my answer? What would my answer be? 5. Okay? So here's the thing. My answer is 5, and all I have to do for this is make this happen. So in my original problem, to make that happen, I'm going to square both sides, and look, it's appeared exactly what I'm looking for, and I would square that side as well. And you can see already that this answer that I was looking for, all of this, which is here, is just equal to this canceling out and equaling 5 in the end. Okay? Alright. Let's see. I think we have time for one more problem. Let's see. So let's try the third one. I don't want to do too much too, because you still have to read. Okay, let's do that. Let's try this one before we leave. We have x minus 3 quantity squared is equal to x plus 2 quantity squared. And I want to find x. And this is a grid-in, so there's no multiple choice. How could we go about this? What do you suggest?
You get rid of the squares.
Okay, so if I square root both sides, which if you do to one side you can do to the other, then I'm left with that. You with me? Then what would you do? Combine like terms? How many x's do I have left? 0 x's, right? Because if I subtract x from both sides, then all I get is that. You with me? So, real quick, because I want you to still develop a good awareness and understanding of how to use this calculator. If we were to solve this and put x minus 3 squared, so parentheses x minus 3 squared, and say that it's equal to parentheses x plus 2 squared, and say solve for x, let's see what it gives us. It actually gave us something. You with me? So it gave us something where back here it almost felt like it shouldn't give us something. Okay? The reason why this is different is because you had an equation that involves something like this setup. What's my answer, guys, to x squared equals 81? It's not 9. Because we are putting the square root, it's actually plus or minus 9. Okay? Because 9 squared would give us 81. Guess what? Negative 9 squared would also give us a positive 81. So that's why this one's a little bit weird. What we would have to do is distribute our original blue pieces. Okay, let me go ahead and take that off so you can see it. And it's really that we can't just square roots things, and you'll learn and understand where and why. But this is another x squared minus 6x plus 9. Remember, it's like two of these foiled out. And the right side is x squared plus 4x plus 4. And now it's about getting everything to one side. So if I subtract this, how many x squareds do I have? 0. If I subtract this, how many x's do I have? Negative 10. So I'm going to subtract that. What do I have over there? 4 minus 9? Negative 5. So x is 1/2. Okay? Alright guys, we'll call it for the day. I will post this and I'll send it through Remind in case you want to look at it at a later time, and you're more than welcome to. Please read chapter 12. Do the homework. Do the drills at the end and throughout the chapter, and also your Delta Math is up as well, okay? Alright, I will see you guys next time. Text me if you have any questions.